So good afternoon, class. Today I am going to start chapter motion with you people. Can anyone tell me that what you mean by motion? What do you understand by motion? If any glass is kept at any place for 2 days, can you say that this glass was in motion?
No, ma'am.
Then what will you say, that the glass was in rest?
Yes, ma'am.
Okay. If the
Yes,
same
ma'am.
glass is kept in the same place for 2 days, 3 days, 5 days, and it has not changed its position, means what? That the object was not in motion, it was in rest from 2 days. With time, its position has not changed, it has not traveled. So that object will be said to be in rest. Okay. In the class, when the teaching is going on, what is your mode? It is in motion or rest? Is it in motion or rest? So it is in rest. क्या आप कहेंगे? Rest. If there is no movement with respect to time, then what we'll say? We'll say that the object or the body is in rest. So in physics, we deal mainly with the two main topic. Whenever we'll discuss about anything, we'll say about the object is in motion or in a rest. Isn't it? We are experiencing different things. We are traveling from one place to another. So what is that? That is motion. From home you are coming to school. From school you are going home. That situation is what? Of motion. But when you will sit in a particular place and you are not going to change your position, that will be said to be what? As a rest. ठीक है? So in physics there are two conditions, one is of rest, another one is of motion. And because of this rest and motion, we are able to experience different kind of situation. We can see days and nights. We can see the changes of the season. So why all these are taking place? Because of the movement of the earth. Earth is revolving around the sun. Earth is rotating on its axis. That is causing what? That is causing rotation is causing what? It is causing the change of day and night. And that revolution around the sun is, we are able to experience change of different season. Even in chemistry, states of matter, from one form it is changing into another form. One state is changing into another state. Why this is happening? Why this is happening? Can anyone tell me why this is happening? Change of state is taking place because of what? Because of what? Because of the motion. Particle is gaining energy. It is vibrating. It is moving apart. It is changing its position. And due to the change in position, what is happening? Change of state is taking place. So in atoms also there is motion. There is rest. In molecules also there is motion. So everywhere, in biology also you can see motion. Last chapter we have studied about plasmolysis, endocytosis, और क्या पढ़े थे? Exoosmosis, endoosmosis. So what is happening there? Movement of the water is taking place from the cell to the outside environment, or from the outside environment into the cell. That is also motion. If there will be no motion, then many of the function is going to stop in the cell. Okay. So motion, how we will define motion? An object is said to be in motion if it changes position with respect to what? Time. And when object does not change its position with respect to time, then it is said to be what? It is said to
Rest.
be in rest. It will be said to be in rest. So there is two situation. One is motion. Another one is what? Another one is rest. And all types of motions are relative. They are what? Connected, interconnected to any other point that is called what? Reference point. Reference point क्या है? What is reference point? It is considered to be as an origin. Okay, we can take any origin or any reference point, and with the help of that we can tell whether the object is in rest or motion. For example, in your NCERT book also it is given, situation is given where a passenger is moving by a bus. So when a passenger is moving by a bus, what can you tell for the passenger and for the person who is standing outside? If you will talk for the person who is standing outside the bus, what he will assume? That the bus is in motion. Bus is in motion.
Yes, ma'am.
And for the
Yes, ma'am.
passengers who are sitting inside the bus, they will assume that the person who is standing outside is moving backward, because bus is moving forward, and that when you move forward, the things which are stationary will move backward, isn't it?
Yes, ma'am.
So these are the different situations where a reference point, with the reference point, the motion and the concept of motion or rest is going to change. With respect to what? With respect to any reference point. There are different types of motion. What are different types of motions? If any car is moving on a road, straight road, what kind of motion it will be? If the car is moving straight on a straight road, what kind of motion it is? Linear motion. स्ट्रेट पाथ में मूव कर रहा है तो ये जो मोशन हो रहा है क्या होगा? ऑब्जेक्ट इज चेंजिंग द पोजीशन, इट इज अ लीनियर मोशन. When an athlete runs in the field, when an athlete runs in the field, in the cricket field, then what kind of motion it is? What kind of motion? What
मैम
kind of
सर्कुलर.
सर्कुलर? क्योंकि क्रिकेट का फील्ड कैसा होता है? सर्कुलर ही ना होता है, ग्राउंड जो होता है, और उसमें जो वो रन कर
Yes,
रहा
ma'am.
है, that will be a kind of what? A kind of circular motion. Okay, then so we have discussed about linear motion, we have discussed about circular motion. What about rotatory motion? Can you give any example? Rotatory motion? Yes, very good, Gayatri. It's what? Movement of the earth on its axis, or movement of the earth around the sun is called what? A rotatory motion. With respect to anything, that is rotation. Fan also good. That is also an example of rotatory motion. Oscillatory motion, oscillatory or vibratory, that we can see in the change of state. जहां पर change of state हो रहा है, वहां पर क्या हो रहा है? एक स्टेट से दूसरे स्टेट में आते हैं तो क्या होता है बताइए? Particles starts vibrating. Yes, pendulum is also an example. Particles start vibrating, it moves apart, so there is motion. There is motion. So yes, motion of pendulum is an example. Then change of state is an example of what? Of oscillation, oscillatory motion. moving sewing machine is oscillatory. No, you cannot say that. Cannot say that. Okay, so these were the different kind of motions. Now there is, on the basis of what? On the basis of the distance traveled and the time taken, balance machine, yes, balance machine motion. हाँ, different examples are there. Moving, swimming, yes, motion. तो कौन सा मोशन होगा? झूला जो है वो कौन सा मोशन होगा, बताओ कौन सा मोशन होगा? Yes, oscillation, correct. So different examples. See, physics is related to what? Physical world only. We will get the example all around ourselves. We will get the example from everything from what we are seeing around ourselves. Okay. So there are two kind of motions on the basis of the distance covered and the time taken. One is what? Uniform motion. Another one is a non-uniform motion. So uniform means what? Uniform means uniformity in anything. And what uniformity we are talking about? We are talking about the uniformity of a distance and time. Okay, we are talking about distance and time. So uniform motion relates to uniform distance. That means equal distances in equal interval of time. Okay, equal distances in equal interval of time. When the distance will be equal, suppose I am taking this example. Wait a minute. Okay, so uniform motion, when we are going to consider, suppose I am taking a point A and point B. The total distance of this point A and B is how much? Suppose it is 200 kilometer. And there is a stoppage at C, D, E and B. Okay, this is of 50 kilometer, this is of 50 kilometer, this is of 50 kilometer, and this also of 50 kilometer. This is equal distances, and the time which it is taking to cover from A to C is 1 hour. This is also 1 hour, this is also 1 hour, and this is also 1 hour. So in every 1 hour, it is covering a distance of how much? 50 kilometers. That means equal distance, equal interval. Equal distance, equal interval. So when an object covers equal distances in equal interval, that is called what? Such kind of motion is called what? Uniform motion. उसको क्या बोलेंगे? Uniform motion बोलेंगे. But suppose I'm taking another example. A, B, this is 200 kilometer again. This is 100 kilometer. This is 70 kilometer. And this is 30 kilometer. And this is here it is taking 2 hours, taking 1 hour. Here again it is taking suppose 3 hours. Okay, can it happen or not? ऐसा हो सकता है या नहीं हो सकता?
Yes, ma'am.
हो सकता है. Quite possibility is there. When you will be stuck in any traffic jam, then it can take 3 hours to cover 30 kilometers. Okay, so there is possibility in this. So what is happening there? But one thing, एक मिनट यहाँ पे 1 hour, यहाँ पे भी हम 1 hour कर देते हैं. Unequal distances in what equal interval of time? Unequal distances in equal interval of time. So this will be example of what? This will be a non-uniform motion example. You can also take the example of say train. When a train starts, initially it is running very slow. So at that time, what is going to happen? It will cover less distance. But again, after certain hour, you will see that the distance cover is something more. So when unequal distances will be covered in equal interval of time, or equal distances will be covered in unequal interval of time, even that is the possibility, and such a kind of motion will be called what? Non-uniform motion. Okay, everyone? When anything is dropped from a height, okay, suppose this is the building, this much tall is a building, this is a very big building, and if you drop anything from here, okay, if you drop anything from here, so first of all it will be like this. Now while it will come closer to the surface of the earth, okay, it will cover more distance because there will be pull from the gravity. It will be pulled by the gravity of the earth, gravitational pull. Because of that, what will happen? यहाँ पे ज्यादा distance ये cover करेगा कम समय में. So this is also an example of what? इसको क्या कहते हैं? Freely falling body. What it is called? Freely falling body. So freely falling body or a train moving, or you can even take the example of this morning walk. In morning walk, is our motion same all the time? When you are cycling, is your motion same all the time? Is it same? No. If initially you will start with great energy, then at the end what will happen? You are going to lose your energy. Your energy will be lost. So all these are examples of what? Non-uniform motion, where maybe the time may be the same, but distance will be what? Unequal. Maybe the distance same, but time might be unequal. So all these are what? Examples of non-uniform motion. I hope the point is clear to you. Now next we'll discuss about what? We'll discuss about distance. Distance. Distance is what? If suppose I am drawing this figure, A, B, C, D, E, F, G, H, I, J, K, L, M. Okay. A man started from point A, and his final destination was what? M. He has to reach this place. So the distance the path which he took, this path he took, that will be the total distance covered by the man. That will be the total distance, or you can say the actual path which is covered by the man in a given time with respect to time. Take one more example. A, B. It is 200 kilometer. Okay. A man started from A and reached B. The total path which he covered is what? 200 kilometers. That is what? That is 200 kilometers. So that will be considered as the distance covered by the man in the given time. This is what? This is called the distance. Suppose this figure I am taking. A, B, C, D. This is 20 meter. This is 15 meter. This is, suppose this is again 20 meter. Okay. So what will be its distance? What will be its distance? This plus this plus this. That means total कितना हो जाएगा? 55 हो जाएगा. 55 meter distance हो जाएगा. So this is what the total path. No matter what is the direction. No matter what is the direction, the total path which will be covered is what? Is the distance. That means for distance, direction is not important. Only magnitude is important. What is important? Magnitude is important. Direction is not important. Here you can see each time the direction is changing. Direction is changing. What we are taking care about? We are taking care about what is the total distance which he has covered on coming from A to M. So distance क्या होगा? That is the total path or the actual path which is taken, which is covered, which is traveled. With respect to what time or with respect to any reference point? With respect to any reference point. Okay. One thing more. Now this was about the displacement, distance. Now displacement. What is displacement? This is the longest path. Longest path. But displacement is what? Shortest path. Shortest path from initial to what? To final. From initial to final. So, if suppose I am talking about this figure, this from A, B, C, D, E, F, G, H, I, J जो भी है पूरा ये यहाँ तक आ रहा है, ठीक है? This is entirely coming this side. Now, when we are talking about the displacement, so this is the initial. This is what? This is initial, and this one is what? This is final. This was the starting point and this is the final destination. So displacement will be what? Shortest path from initial to final. तो ये आपका shortest path ये वाला हो गया dotted line. This is your what? This is your displacement. क्या है ये? This is displacement. And displacement direction is required. In order to know the displacement, what is required? Direction is required. So displacement is a vector quantity. A quantity which requires both magnitude as well as direction is what? Is a vector quantity. Displacement is always less than distance. You can see why? Why? Because it is the longest path. Since it is the longest path, it will be always greater. And this is the shortest path, so this will be always smaller than distance. I hope the thing is clear to you.
Yes, ma'am.
Now some questions I am giving you. Please note it down as a homework. Note down. Is it possible that is it possible that magnitude of is it possible that magnitude of displacement and magnitude of distance same? Explain with example. Second question. Can the magnitude of distance taken as negative? What type of graph you will get when you plot it for uniform motion? When you plot it for uniform motion. What can you say? What can you say about the motion of an object? What can you say about the motion of an object whose distance time graph is a straight line? All of you have noted?
Yes, ma'am.
What does the path of an object look like? What does the path of an object look like when what does the path of an object look like when it is in uniform motion? Last question. An object has moved through a distance. Can it have a zero displacement? Can it have a zero displacement? If yes, support your answer with an example. If yes, support your answer with an example. An object has moved through a distance. Can it have zero displacement? If yes, support your answer with an example. Support your answer with an example. I hope all of you have written.